Today we're building some walls, some some big, fat, beautiful walls. All right, stop mocking. Okay, now walls and gates. Now you're given a n times n 2D grid initialized with these possible values. Okay, -1 is a wall or obstacle. 0 is a gate, and INF, well, it's not international blah 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 fund. That's IMF. Okay, sorry. Infinity means a empty room. We use the value 2 to the power of 31 minus 1 equal to this string of number, phone number, okay? To represent an NF, as you may assume that distance to a gate is less than 21474836647. Now, fill each empty room with the distance to its nearest gate. If it's impossible to reach a gate, it should be filled with INF. For example, given the 2D grid like this, and after running your function, the 2D grid should be like this. Okay, so INF becomes 3 because the closest gate to the room to the gate is 3 distance away, 3 steps away. 1, 2, 3. 1, 2, 3. Right? And on the other hand, at this INF, the closest gate to this room is 1, 2, 3, 4. Okay. And all the negative ones are got around. So it's a pretty straightforward. Now, this is a very typical graph traversal problem. Okay, so for every graph traversal problem, we have 2 solutions. One is breadth search and the other one is depth search. Now, I personally don't like depth search because it can lead to exponential time complexity. So you can get into a branch too deep, so deep that you can't come back. Alright? Now, so breadth search is where we're going to start with. Now, right now, what I'm thinking right now is that my first solution, okay, which is kind of the brute force way, I think we can start with we can get all the rooms we can find and then put it into a queue, and then for every room we're going to do a breadth search to see which room can we get to first, right? Since breadth search is going a breadth scale, a wide scale search, one at a time, one step at a time. So the room that we first get to is the closest room we can get. So the runtime of this depends on how many rooms we have. So let's say M, and you know what? Let me write this down so that so first solution is to get all rooms, and then for each room. Wait, I forgot to start my timer. Sorry. You know what? So I think I just spent like about 3 minutes. So I'll start from 27 minutes. All right. If that's the wrong time, I'll correct it later. So, anyways, so first of all, we need to get all rooms, and then for each room, we are going to do a breadth search. All right, and until we get to the room, get a room, right? So this is the closest distance, to a gate. So the runtime of this, if we have n room, and we're gonna have so we let's say we have x room, and then for every room we have to traverse n times n time. So can we do better than that? Can we do, at least can we get rid of the x and get m times n? So let's take a look at this. What we care about is the distance to its nearest gate. Okay? The distance to its nearest gate. Alright? So how about we do it reversely? And try to see what room can we get to? What rooms can we get to from a gate? So okay. So now the second solution would be, let's get all gates. Alright? And then for each gate, for every single gate, we'll move one step at a time. For each gate, I say move one step at a time for each gate. Now we're going to move one step at a time for each gate, and then once we reach a room, we'll mark the room, because we can pretty much sure that the room that we first get to, the room that we get to, must be the shortest distance to the gate. There's no other steps that is shorter than the first room we get to from a gate and a room. So if you still don't understand, I think we can you can do some research on breakfast search, and because of time, I don't have too much time explaining into details. Okay, now for move one step at a time for each gate, and then we're gonna mark the distance. If we can reach a room, if get a room, we're going to mark it with number of steps. Okay, so that's it. All right, so let's get started. Now, first of all, I think we definitely need to move. We need to move around the graph. So we need 4 steps. So move to the left, move to the right, and top and bottom. So in order to do this, we need an array which is called we're going to call it an int, and we say moves is equal to so this is going to be 0 and 1. Oh, well, you know what? Let's move to the left first, and move to the right, and move to the top left. Move to the +1 is move to the left, and then and move to the right. Move to the right, move to the left, and then move to the top, and then move to, well, actually this is move to the bottom, and this is move to the top. Okay, because the matrix is represented in the upside down way, so the -1 here is actually moving to the top if we look at it from our perspective, if you know what I mean. Anyways, now, so, okay, we have the moves, and now what we need to do is we need to have a linked list or a queue to put all the gates, right? So since, the runtime of this, obviously, since we are not doing a breadth search every time we get a room, so it's going to be n times n, because we are iterating all the gates at once. All the gates at once. We're doing breadth search for all the gates at once. Okay. All right. So next, I think it's time to create a queue. All right. So because this is the fundamental step of a breadth search. So for queue, I think we need to put the coordinates to it. Okay. So for coordinates, I think what I would do is, let me try if I can. I think we should create a class called cell. Okay. So class cell, it's called int. Well, it's the wrong class, declared in the wrong function. So this is gonna be class cell so this is x, and this is y, and then for the constructor we need cell int x, int m, and int y, n, and we will have this x is equal to m, and this y is equal to n. So this is how we're gonna have object to represent our coordinates. All right, so Q and cell. Okay, we're gonna have say Q. Let's just call it Q. Right, new linked list cell, and then for int is equal to I equal to 0, I less than rooms, dot length I plus plus. So this step what we're trying to do at this step is we're trying to put all the rooms, all the gates, all the gates into this rooms 0. I assume the matrix is valid. So plus plus. So what we're doing right now is we are putting all the cells all the gates into the queue, so that we're going to start the breadth search for each gate. All right. So now it's if rooms. So this is going to be I n j is equal to 0. So 0 is a gate, right? Okay, right, perfect. So if it's a gate, then we need to put it into a queue. So we're gonna have a new cell I j. Okay. Now, all right, this is done, and I think we maybe need. Okay, we maybe need a variable. I think we might need a variable to store the current number of steps. But I think since we're starting from a gate, so every time we move on from a gate, we can just increase 1 and then put it into that room, and put it into the cell of the value of that cell. Okay, so I think that's okay. All right, so add this, and then we are going to while q empty. or queue size is not equal to 0, right? So while queue size is not equal to 0, what we're gonna do is, okay, first of all, we are going to pop it, right? So we need cell, its temp is equal to cube.poll, right? So we're gonna pull this so this is the first gate we're gonna get. So and first of all, should we mark it visited? No, I don't think we need to. So what we need to do next is that if we're gonna check if the current room, if the next step, so we're going to move to the left, to the right, and the top and the bottom, right? So for the next step, we're going to check if this is an obstacle or not. If this is the obstacle or if this is something has been visited, okay? So now, we should do for I is equal to 0, I less than 4, and I plus plus. Okay, and we're going to do a function. We're going to add the next step to the queue, right? Add to queue. Let's call it add to queue. So what we need to do is, first of all, we need to get the x coordinate. So it's temp.x. You know what? We don't even need to get that. So it's gonna be temp.x and temp.y, but not yet. We're gonna add temp.x plus moves, or let's call it move. Let's call it move I 0 and move I plus this. Okay. Now we have the coordinate of the next step, and for now, since the gate is 0, the value of gate is 0, so we can just add 1 to the value of the current gate, of the current cell, meaning the number of total steps, right? So if right now I'm a gate, I'm 0. If I move on to the next available spot, I can just add 1 to 0 and mark it as the value of the next step. Okay, so that's perfect. So actually, yes, so we can do that. So rooms, this is gonna be, you know what? I'm sick and tired of writing temp. Let's do x temp.x and y is equal to temp.y. Okay, so we have x plus move and y plus move, and rooms is, okay, so we're gonna pass room and we're gonna do the condition determination in the function. So we're gonna pass rooms, and then I think that's about it. Of course, we need to pass the queue so that we can determine if we should add it or not. So this is going to be queue, and then I think we're good. So now we need to write this. Excuse me. So now we need to write this helper function called add to queue. So it's gonna be private and the void add to Q. Right? So it's gonna be in X and Y, and we have a room matrix, and we have a Q is cell and Q. Okay. Now, first of all, now we have the Q. Now we have the coordinates. We need to determine if this is less than 0. Okay, so if this is less than 0, or X is larger and equal to rooms dot length, or Y is pretty much the same, less than 0, or Y is larger and equal to rooms the length of the first column, or there's one situation, if it's obstacle, right? So, right, if it's obstacle, if it's -1, then we also don't want to add that is equal to -1. Or, there's one more thing. If it's been visited, we don't want to visit a room that has been visited, right? So, you know what? I think it's better, it's cleaner to do it this way, because these are three conditions. Okay, so this is the boundary problem, and if this is equal to 0, and if rooms x, y is, so if it's been visited, which means it's not equal to infinite integer dot max value. So if it's not equal to the max value, that means it's already been visited, because it has the number of steps from the previous iteration. All right. Now, if this is the case, all right, then we just continue. We don't give about it. But if it's not, now that's the interesting part. Now we need to we need to add the current cell to wait, hold up. We need to have the length of the current. Okay, so it's gonna be rooms, and rooms is gonna be x, y. Okay, so we need one more thing, which is the length of the previous step of the previous cell. Length of the previous cell. The number of steps of the previous cell. Let me put it this way. So it's going to be, because if this is the case, there's no way that we will get to know what's the number of steps in the previous step. Okay, so all right, now this is the steps, okay? And okay, now it's time to say, okay, rooms x, y is equal to steps rooms plus 1. Okay, and one more thing, we need to add that. Q add. So this is gonna be, I think it's for Q, is it pull and push, right? Let me see. Q Java 8. Offer, add, offer, return special. I think it's for time being, I'm gonna just use add. All right, so it's gonna be add, and we're gonna have a new cell, which is X and Y. Perfect. Okay. And I think that's it. That's pretty much it. And I think we could run it with some test cases. Let's see. $37. What? Continue outside of loop. Oh. Why do I say continue here? So just return. Okay, that looks about right. All right, perfect. Let's submit it. So basically the idea is to breadth-first search for every gate. So I don't think there is any wrong with this. All right. Accepted. Perfect. All right, cool. Yes, so we have successfully built a wall. Yes, so this, you know what, let me stop the timer first so that it won't scream. Okay. Yeah, so the point of this is to, sometimes you have to think outside of the box. The question wants you to find distance from a gate to a room. But in order to do that, we need to iterate every room. So that is not that is not very convenient, because I mean we can do breadth-first search for every single room to a gate, but we have to iterate. We have to iterate through every for each room. We have to iterate every single gate to know which one is the shortest. But it's not the same way the other way. For the gate, because what we care about is if we can reach to a gate or not. So we start from a gate and see, and once we reach a room, we immediately know that this is the shortest distance. Okay, now thanks for watching, and as always, happy coding. I'll see you next time.